Hello guys, hope you all doing extremely well. In this video, I'm going to solve and explain this problem from today's Leetcode contest, and it is a medium level problem, pretty simple, but as others I got it too wrong in first attempt and got it right in uh, later attempts, and pretty similar problem. Let's get started. It is given here. We will be given four integers sx, sy, fx, fy. Here the starting coordinate will be denoted by starting coordinate x, and y will be denoted by xs, sx and sy. And similarly, ending coordinates means coordinate of ending cell or destination cell is denoted by fx and fy. And we are also given a non-negative integer t, which will be denoting time. We have infinite 2D grid, alright, and we have to move from the starting cell to destination cell. Each second you must move to any of its adjacent cell. This is very important and it's going to be very useful in managing edge case in this problem. And because I didn't pay attention here, the problem showed incorrect answer in the first attempt. What is given here? We can't be still at any second. We have to make move to any of its adjacent cells. Now, what is this adjacent cells? How many cells are adjacent cells? So the cell just around, just the cells which are just neighbor of the cell on which we are currently present are adjacent cells, and for any cell there are going to be 8 cells around it, like this. If I am here, if I am here, then there are going to be 8 adjacent cells. 1 2 3 4 5 6 7 8, like this. Okay, we have to find out that if we can reach the destination cell after exactly t seconds or not. Now let's find out. Now let's understand how I have done it and how I have reached approach. Suppose this is the starting cell, starting, and this is destination somewhere here. If if the time given to me is very large, means 100 seconds or 10,000 seconds, and I have to reach that at 10,000 second. Can I do that? Yes, of course I can do that. If the time is very large, I can just roam around anywhere. I can make move here, and as I can visit the same visits and again, I can move here, I can move here, here, and just I can also return to the previous cell, here, here, here. I can roam around many times till I reach that 10,000 second, and at 10,000 second I can reach there. So I am not concerned about the maximum time. If the time is very large, means if the time is larger than the minimum time, I will tell you in a while how I'm going to calculate the minimum time that is going to be required from starting to destination. And the time, we cannot reach it before that time. Anyhow, we cannot take lesser time than that minimum time. But if we have a time larger than minimum time, then definitely we can make it at any second, no matter how large it is. Alright, now I hope that it is clear till now. It is possible because we can visit same cell again and again, and we can roam around anywhere. So I hope that it is clear till now. Now the thing remaining is that minimum time. The minimum time can be, see, a route I can choose is first second, second second, third second, fourth, fifth, sixth, seventh, eighth. At the 8th second I can reach if I follow this path. Is there any shorter path than this? Yes, there is. If I follow this path, 1 second I can reach here, and at second, at third, at fourth, at fifth. This is alternate route, and this takes less time. It takes only 5 seconds. So I'm only concerned about this minimum route. And if you try to find out, there cannot be any route better than this, because you try, if even if I go through this route from here, 1 2 3, let me take any other color, 1 2 3 4 5 6, then also it took 6 seconds. this is the this is the best route which takes minimum time. It is destination, and it is third second, it is fourth, it is fifth, it is minimum time. So if in the problem, this is the problem, means this is coordinate given to me are sx and sy are 0 0, this coordinate, and destination coordinate is here, the x coordinate is going to be 1 2 3 4 5 5, and y coordinate is going to be 1 2 3 minus 3, because it is below. So if the time given to me is time greater than equal to 5, then I will return true. That's it. Just I have to calculate the minimum time. And how I'm going to calculate the minimum time? I'm going to calculate this through by calculating this, how much I can travel diagonally. See, the time is saved when I am traveling diagonally like this. So it will be it can be find by seeing the difference between the x and y. How much difference is between x coordinate? 5. And if I take the absolute difference between the initial y coordinate and final y coordinate, it is 3. So the maximum path I can travel diagonally is determined by this difference of the x coordinate and y coordinate, and it is going to be equal to the minimum of both. Here 3 is minimum. So I have traveled across 3 cells diagonally. Okay, I will find out the difference between both the x coordinates and y coordinates of starting and ending, and I will calculate my path travel diagonally through the minimum of both. After that whichever remains, means I have traveled this much in y direction, because I have taken this, and y direction, and also in x direction. See, I have traveled in y direction, and I also increased my x, also increased my y. So this much times I will increase my starting x and y. Okay. After that, one will be equal. After traveling diagonally as much as possible, one of this x and y will be equal to the final. So here y will become final. Initially y is 0. I will add 3. Y will become 3. X is x is also 3. After traveling 3 units of time diagonally, my x and y have become now 3 and 3. This is one of them will become equal to the final coordinates x and y, and other will not be equal, and that I will calculate. This final x is y, and we are at 3, so we need two more seconds to travel the remaining distance, and total we got 5 in this way, and this is the minimum time. If the time is given lesser than 5, then we return false, and otherwise we are going to return true. The things that we need to take care about, that the two coordinate sx sy, fx, fy. It is not necessary that these are going to be as fx and fy are going to be larger than sx and fy. So we need to take care about it ourselves. Here the sign do not matter, only absolute distance between the x and y coordinate matters. So what we are going to do, we are going to take minimum coordinates, minimum of sx and sy, sx and fx in sx, and maximum of sx fx in fx, so that it will become more easier for calculating, for finding out the difference. All right, and just that's it. And we need to take care about edge case is that when we are currently standing on the destination, means starting is equals to destination cell. When starting cell is equals to destination, here what we can do, if the time is given as 0, yes, in 0 second we are on destination, then we have to return true. At 1 second, if we are at destination, source and destination are same, suppose this is the source and this is the destination also, because it can be same according to the problem. Now if it is same and we have given the time as 0, yes, we are already on a destination, so we will return true. If the time is given as 1, then we have to make a one move. We will go one place, here or here or here, means out of this destination. So in this case we are not currently at destination, so we'll return false here, because after making move we'll move out of the destination, and at 1 second we are not at destination. And for any larger value, I'm talking about this condition when this is true, this is the condition when starting is equals to destination, then only. If any other value 2 3 4, that after going away from the destination I can reach again to destination if any other value is given. If 2 is given, then I will go, and at second I will come back. If 3 is given, I will go here, I will go here, and I will come back to destination, like this. So 3 at 3 second also will return true, true, and for any other value I will return true, because at any larger time I can come back to destination if I'm already standing on destination. That's it. Now I'll be explaining the code and it will become more clear how I have done. See, here I have separately managed that edge case when the source and destination are same. I'm returning true when time is given as 0 or time is greater than 1. At time is equal to 1, I will return false here straight away. I am not going to make any calculation further. In these statement, I have only ensured that starting x coordinate remains minimum of starting coordinate x coordinate and ending x coordinate. Similarly for y, I've done just this in these statements. Now here I have calculated the time for traveling diagonally. So I have to travel diagonally as much as possible, and I have calculated here, and I have already explained how I am doing this. I am just calculating the minimum of the differences of x coordinates of starting and ending and y coordinates of starting and ending. After that I have traveled diagonally. Now I will travel, I have added how much I have traveled diagonally to the x coordinate and y coordinate, and now I will add in time that much cells are remaining, and now I will travel linearly. I will not travel diagonally because I have already traveled. Now it is not possible me to travel diagonally, because either this has become equals to this or this has been already become equal to this. So either of this is if condition will execute, and the remaining time for the remaining distance will be added to the time, and this time is containing the minimum amount of time required. So here I am checking if the minimum time which I have calculated and the time which is given to me is larger than that minimum time or equal to minimum time that I have calculated, then I will return true, otherwise I will return false. And this is the whole problem. It is already accepted. Now I am showing you, I am submitting it for showing you. Yes, it is accepted. Hope you understood the concept. Thank you.